So once again, what are you working on in class today? The skills. What are you working on in class today? The skills worksheet. This is homework tonight for tomorrow. But realize, guys, there's like some reminders, there's some review, and then I've gone ahead and kind of made the problems similar to what you saw in your worksheets and in your quizzes. I've made them problems kind of similar to like what I would ask on a test. So do you guys notice how some of the problems are missing? You don't have to go back and do the ones that are missing, just do the ones that are on the worksheet itself, okay? But anyway, at the end of class, we will be powwowing and see how you guys did, but we have this homework to grade right now. So I have the evens up here on the screen, or I'm pulling them up here on the screen, I should say. There they are. Wait a minute! As you guys are looking at homework from last night, did you have any graphs on there at all?
No.
No. Ooh. Ooh. Did you need to have any graphs on there at all? No, why not? Yeah, I totally told you yesterday. What were you supposed to cross out in the directions? What were you supposed to cross out in the worksheet? And what were you supposed to not do in homework? Yeah, don't stress about it. Lines weren't this year, they were last year. I'm not saying they're not important, they really aren't. But not important for this test. Okay, so checking it out. You do not have to graph the function in its inverse, even though it does have that cool little fold that we saw when I pulled up the TI calculator yesterday. All you need to be grading, guys, are the functions. Did you figure out that the inverse, our book didn't go all snazzy Algebra 2 on you. That's a bummer. It could have done that snazzy Algebra 2 way of writing the inverse. Instead, they were like, nah, we'll just call it by a new name. Okay, fine. You can do that too. They called it by G, but a lot of you guys might have just called it by Y equals. So number 18, 5 minus x over 2. Number 20, x minus 3 over 2. Let's make sure we're doing our homework that way. Number 22, 7 minus 2x over 3. Number 24 was a bit tricky. Number 24 was a bit tricky. Negative 5 times the square root of negative x. It's right back there. It's the one that I also had on the screen just a second ago. Yeah, if you're up there at the front, not in your seat, you should be super focused. Otherwise, I might need to send you back to your seat. I'm not sure why you moved that. Without asking, especially. Number 30 is a function and 32 is not. Number 30 is a function and number 32 is not. Now guys, I have the problems right over here on the side. Is there anything that you want to look at? The ones that are finding the inverses or the ones that we're trying to do passive fix to? 22? This one right here? Anything else, Andrew? 21 and 22? Alright, you guys lead the way. You don't need me. What were you supposed to be doing? Diana, John, Caleb, what's up? Do you guys need me?
They're just confused on the homework.
Okay, then ask me a question. What are you confused on?
I'm good. That was Jerry.
Okay. I think I just got it wrong.
Which one?
Number 18.
Number 18?
Yeah.
Okay, so hold on. Let's start there and then we'll go to 22 because those are the two evens that we just checked. Because you guys might have just gotten them wrong and not realized why you got them wrong. Don't go peek at number 21 real fast. But guys, for this entire section, what was the process? 3 S's. Do you remember what they were? Yeah, wait a minute. Don't you guys all have your worksheet in front of you? Andrew's doing it right. He's reading exactly what they were from yesterday. Kayla's doing it right. What about the rest of you guys? Sean, wrong worksheet. Look at 10-4B.
Oh.
Yeah, this is the homework that we're grading, yeah? There you go. We're grading the homework. That was from this. So we're trying to remember the first 3 steps, which is exactly what you were supposed to be practicing last night. So number 1 is set. Set what? Set f of x equal to y, right? Or put y for f of x. So what can I do with all of these f of x's to make it easier in my brain? Yeah. Okay, what's step 2? Switch. Good. So for number 18, John, did you go ahead and take this guy off to the side? Let me go ahead and write that switch real quick. Switch x and y, right? Oops. X. We'll do it that way. Okay, so that would be x equals, keep going, Kayla. Okay, and And what's step 3? Once we've set the y for the f of x, we've switched the x and y, then? Yeah, so check it, John. What'd you do first to solve for y?
Subtract 5.
Perfect. And as soon as you subtract the 5, you now have this multiplication of a -2 that you undo. And how do you undo it?
Divided by 2.
Now, why is the -2 going to cause some issues? Yeah. Now, pause. You're right if you wrote that. You're totally right if you wrote that. Is that how the book wrote it, though?
No.
Because remember from what I said yesterday, does anybody remember? What don't they like leaving in the denominator? Yeah. They don't like leaving the negative in the denominator, so instead, do you remember how it has to distribute that whole, like, we can't kill a seal thing? And I know it's weird because it's division, but it's like multiplication. I can bring up the negative, but I just have to bring it up to both. Now, some of you might have written it like that and not realized it's the exact same thing. They just wrote it this way. Does anybody know why they would have written it this way? Isaiah, what do you think? Why did they write it that way instead of that way? It's the same thing. I totally agree. Does anybody else have an idea? Which one looks easier in your brain? -x plus 5 or 5 minus x?
5 minus x.
Okay, it depends on whether or not you remember y equals mx plus b from last year. Some of you might be stuck in that mode. X always goes first. But a lot of this, just looking at it, this looks cleaner. This looks cleaner. That's pretty much all it is. So, John, I don't know which way you wrote it. If it's this, if you wrote it this way, it's the exact same thing.
Oh, yeah.
If you wrote it this way, it's the exact same thing.
I wrote it -x plus 5.
Okay, yeah, that totally works.
Okay.
Yeah, so you had it perfect. As long as, was there a 2 in the denominator positive?
Yeah, it was positive.
Good. Perfect. You would have had all the points on the test. Yeah. And that's a good thing for my test, or a good thing for you guys that my tests are mostly fill in the blank, right? You guys don't really have multiple choice until your final exam. So you can show me an answer written like this, and I'll give you full credit because you're right. Yeah. So you didn't mess it up, bud. It was just written in a different way. Okay. So then number 22, but it makes sense, yeah?
Yeah.
Number 22. You probably don't like the fractions. I think number 21 was a little easier. So Andrew, let's take your question before going quick to Alexis's. So Andrew, what did you do first on this one then? After making the y.
I did -2.
Oh, careful.
Wait,
Hopefully, yeah. Okay, and then you subtracted the 8. Okay, now guys, follow along with this one because there's something now. You wrote those two separately, right? X minus 8. What do I do? And we had one yesterday, and I did it on purpose. It should be on your worksheet right in front of you. I had one with a fraction. How do we get rid of a 1/3? You can divide, but that's really hard on your brain. If you divide by 1/3, what is dividing by a fraction the same thing as? Multiplying by its reciprocal, technically. But it is kind of the inverse operation, so you kind of have that idea, right? So yesterday I showed, I think we had a 1/2 yesterday, and I multiplied by a 2/1. Was that the worksheet exam? I think it was. But the 1/3 can multiply by 3/1. Just be careful, Andrew. I have to do, what is 3/1? I have to do that on both sides. And that 3 is going to have to distribute to be a 3x and a 24. But then the nice thing is, I just undid that whole 1/3 to get y by itself. You see it? So in Alexis, we're going to use the same idea-ish, except after we switch, yeah? We can't start with this little guy who's being multiplied. We start with this guy over here, right? So Alexis, what's the first step we should do after switching?
Move it over.
Move what?
The 7.
And how do we move addition?
Subtraction.
Got it. So we're going to move that guy to the other side, right? And when we move that guy to the other side, we have x minus 7/2. But this fraction is a bit harder. But guys, Andrew said divide over here. And he was totally right, just it's confusing. So then Kayla answered division of a fraction is multiplication of a reciprocal, along with a few others.
Where'd you get the 4 from?
I have x minus 7/2 equals -3/2 what?
From 4.
Oh, sorry. I didn't know you were over here. I multiplied by 3/1. Just got rid of the 1/3. That's a 3. 3 times x and 3 times 8. Yeah. Sorry. So then what are we going to multiply over here? Multiplying one side, multiplying the other side. No, he's over here nice and safe and sound. I'm trying to get y by itself. Not 3.
Negative 3.
Negative. The 3's down here.
Two over three.
Because I'm doing the reciprocal. Does that make sense? Right? I have to do the reciprocal in order to. Hey, if you have your worksheet from yesterday, I bet you could be doing the examples because you're quick. And I bet you'd be able to fill it in and not need to watch the video. Because what we're doing right now is this. So we're talking about how to do steps 1, 2, and 3. Yeah?
That's too close. I'm on that.
So the 2 reduces with the 2, the 3 reduces with the 3, the negative goes away with the negative. Oh my goodness, everything is gone. Isaiah, we good?
Yes.
Sweet. Y is equal to, wait a minute, what I do on one side I have to do on the
Other side.
Okay.
Jim, okay.
So you could leave it like this. But let's go check out how the book left it. I'm pretty sure they might have done that distribution that we talked about with that 3x minus 24. What number was this? Number 22? Oh yeah, they totally distributed that thing. So when we distribute, that ends up being a negative 2/3 x. I'm going to go ahead and just show it right over here. A negative 2/3 x. And then this will be a negative times a negative is a. Now hold on. Now you guys are fractions. Could we multiply across and get 14 over 6? Yeah. But what else could we do since the 2's are in common? Yeah, another way of saying that is reducing. So we could get plus 7/3. Can anybody look at our final answer and their answer and see if they're the exact same thing, even though they are written totally different ways? How are they the same thing? Hannah, how are we doing, kid? How are they the exact same thing? Same denominator. Good, Levi. This x is x over 1. So couldn't this have become negative 2x over 3 plus 7 over 3? And then what do you do with fractions that are common denominators? Add them together. So it's like the one that Jonathan had. It's negative 2x plus 7 over 3. But how did the book write it? The other way because they thought it was cleaner. But is this right? Yes. Is that right? Yes. Is that right? Yes. Oh my goodness. There's so many different ways of writing some expressions in math. And so part of you guys growing in your math skills is just being able to recognize that it's the exact same thing. That's good, that's good, that's good. So some of you might have thought when you were grading that you were totally messed up, but maybe you're not. Maybe you're just writing it in a different way. Maybe you're just writing it in a different way. Okay. Any other questions? Andrew.
Yeah, I got no solution on number 24.
Oh, we haven't done number 24 yet. But no solution, something went wrong, huh? No solutions usually happen when you have like a negative under a square root. Let's go see what was going on over here. There is a negative. Oh, I see why you might have gotten a no solution. Andrew, you switched to x and y, right?
Yeah.
How'd you get rid of this guy? Okay, and division is the same thing as of the reciprocal, right? What is 25 over negative 1, everybody, to help out? Just negative 25, good Danny. So we end up with negative 25x is equal to, that goes away, negatives go away, we end up with y squared. How do we get y by itself? This is the big concept of chapter 10. Yeah, square roots, good, bring in that radical. So we bring in that radical to both sides. I see why you thought no solution. Because there's a negative 25, but here's the crazy thing with math when you have variables that are unknown. We end up with technically absolute value of y. Now they had you guys only doing part. I kind of let you guys ignore the inequalities yesterday and just kind of write the plus or minus just to make it easier on you. You actually are allowed to write this as an answer, Andrew, because an x is allowed to be a negative number. Now, hold on. 25 is 5 times 5, so I actually could have gone one step more and pulled out a 5, but I could not have pulled out the negative. You're right with that. If you tried to square root negative 25, it wouldn't have worked. It would have said error. I can't pull out a negative from a square root. because of that whole idea that negatives aren't allowed under a square root. But here's the crazy thing. Does x have to be a positive number? Did you see what it said up here that I just kind of crossed out? What kind of numbers are x according to the problem?
Negative.
Yeah, because if it's less than 0 on the number line, it's the negatives, because here's our 0, and less than 0 is going this direction, right? These are all the negative numbers. What's a negative times a negative?
Positive.
Legal, right? A negative times a negative would be legal. So you were good in seeing the negative and being like, oh, that's bad. It is bad in that we can't square root negative 25, but we can leave the negative with the other negatives to make them legal. Does that kind of make sense? I know it's weird. And when you look at the graph, not that you guys had to graph it, remember? That's why what normally is up here is way down here, because all of these would not exist. All of these would be no solution. But because they said x's are negative, it's legal. A negative times a negative is a positive. Yeah. Okay, and so then I just wanted to do a quick recap at the very end of class yesterday. We did this so fast, and it was meant to be so easy. I just wanted to make sure you guys got it. Horizontal line test. We didn't even really talk about what it does, but in the problems themselves they tell you. Horizontal line test tells us whether the inverse is a function. It has to do with that whole vertical line test from a long time ago, probably last year. I didn't teach it to you. I think it was Miss Evelyn did in Algebra 1A. But in order for something to be a function, it has to pass the vertical line test. And if inverses flip over that whole line like we saw yesterday, we can kind of tell the future, in a sense, looking at a function without even graphing its inverse and say, wait a minute, if you fail a horizontal line test, your flipped guy, your switched guy, your inverse guy, he's going to fail the vertical line test. But hopefully that part was easy in homework if you realized all you actually have to do is visualize a horizontal line and ask yourself with like a pencil or a pen, just zoom through it and say, does it hit more than once? Anytime it hits more than once, we're going to say it fails the horizontal line test, which means the answer to this question would be no. It does not have an inverse that's a function. For any time a horizontal line, if you go through the whole graph, would only hit once, it passes. Now, some of you might have been a little bit confused there, but if we were to zoom in, zoom in, zoom in, zoom in, zoom in, it doesn't go flat for a period of time. It's actually just going to go flat for one instant and then keep going up. So actually, it still will hit only once, even there also. So it's going to pass, aka yes. All right, I need to come around and start grading some homework. But hold on, what do you guys have in front of you right now? The skills. Yeah, the skills worksheet. Okay, let's check this out real fast. So we have the 3 sections that are on the test on Friday. Tomorrow you're getting a practice test. And we're going to, after we review all the skills today, see how you do on the practice test tomorrow. That's kind of my goal, trying to give you like a testing experience before the test. And then let you kind of learn from that. What were we just reviewing? What's the very last section we covered? This guy, yeah? So maybe some of you want to start and work your way backwards. Maybe some of you want to go straight to 10-4 and be like, wait, we were just practicing that. I'm going to start with what I'm best on and go back. Maybe some of you are like, no, I'd rather go in order, and that's totally fine. You can start at section 10.1. You guys don't have to do everything perfectly, necessarily. But can I just give you a hint real fast? If you're one of those that likes to go in order, right here in 10.1, because there was something I saw in the quizzes that sadly I can't hand back yet because some people haven't taken them. And I was going to have you guys do them in class today, but instead I think I'm going to do tomorrow because I want everyone to be practicing on the skills today. Can I have all of you guys come back here to the very beginning of chapter 10, and can I have you remind yourselves that you are supposed to be looking at the radicand. You're supposed to be looking at him for 2 things, for tables and domains. If you can't make a good table tomorrow, it's going to be so sad. It's going to be so sad. So hold on, let's review really quickly how we make our tables, and then you can review how to plug in. So, boxing the radicand. Tables, domains. What are those nice numbers that are going to be able to go into this table because the only thing under the radical is an x?
0.49.
It's our great numbers. Throw those in. Some of you would have been looking for crazy, like, shifted ones, and you don't need to. Oh, remember. Man, I thought I got rid of that extra box. I'm sorry. 0.149. I'm not sure anything else will fit on there. Because the next one would be 16, and that's way too big. 0149. But what's different now that I've gotten to this guy? No longer 0149, right? No longer 0149. Can I remind you really fast how to do domains? Domains say, ready? Take the radicand and set it greater than or equal to 0 and solve. We can also think about our transformations. There are two ways of remembering how to make a table for this guy. We have to use those numbers, but use them how? One way is to figure out whether it shifted right and we're adding, or whether it shifted left and we're subtracting from those x's. The other way is we could just find the domain and figure out where to start. Because in this one, guys, if we were to find the domain, we would take whatever's in the box, set him greater than or equal to 0. Wait, we're done. It's already solved. And look, the table starts at 0. Perfect. But what would we do with this one if we were doing domain? Well, Adrian already did it. How would you figure out -3, Adrian? You minus the 3 to the other side. So this would lead us to subtracting 3, subtracting 3. X is greater than or equal to -3. Guys, where do you start your table? Now, some of you are remembering, oh, this has been a while. But I am here to remind you, don't you have a 10-1 worksheet?
Yeah.
And doesn't the 10-1 worksheet give you the thing that I just gave you about domain and setting the domain greater than or equal to 0? And what the range is and how you do that, and some table examples as well? But can anyone remember, if I'm starting at -3, if my domain is saying x greater than or equal to -3, what kind of shift did this have? I know you don't have a table in front of you. I know I told you I'm going to put the table up on the screen Friday for the test, but what kind of shift did it have for this one? If my table's starting here, if my domain is this, what kind of shift? Just looking inside. There's more going on out here. Not up. It's actually down 1. But what's this show me?
Shift left.
Left. Yeah. It's a shift left 3. Now there's a lot more going on. I'm just going to put shift left 3. I already gave you another one. But there's 2 more. There are 2 more. But you're going to need to look at your table in your 10-1 worksheet to fill the rest of that in. But if -3 is my first guy, that means I did 0 minus 3, right? So how do I get the next one? Yeah. 0 minus 3 gets the first one. 1 minus 3 gets the second one. What would the next one come from? 4 minus 3, 9 minus 3. Remember that? Everybody shifts. And as soon as you have x's, can't you plug in to find y's?
Yes.
And as soon as you have x's and y's, can't you graph? And as soon as you graph, can't you think of domain and range? All right. Get out what you need for class today. I'm going to come around. I'm going to grade as many of those homeworks as you have ready for me. I'm going to grade as many worksheets as you have done for me. And you guys are going to be skill testing yourselves, but you're allowed to use any of your old worksheets. You're allowed to ask questions in your groups, but this is homework due tomorrow. And Andrew, I'm bringing it back to you right now. So you can fill in what you already started. Very much going to be grading for the rest of you. If you have it memorized, it's no fun, but if you don't, see how many you get down to. Alright, you guys are just working on the skills worksheet, and I'm going to come around and grade as much as you guys have. So go ahead and get organized. You should probably have out all your chapter 10 worksheets anyway to be using right now. I would get them all up. Get them all up to be using on your skills sheet, right? Alright, find all your worksheets so you can be using them on the skills sheet, and I can give you points. It's a win-win, however you look at it. Get organized, get out all chapter 10. I'm walking around and I can deal with whatever issues you guys have with your work.
I have a question. Was it different online on Web than it was in here last night somewhere?
Yeah, that's why I told you guys in class to change it.
Oh.
But if you have the other ones, Andrew, just realize that these are easier, and if you skip the harder ones, they'll still give you credit. Just for the test, just realize it's not going to be that bad.
Alright.
Yeah.
What?
Remember, it's on Google Classroom, right? Just because that would be good to use for your Okay, so you should have your chapter 10 worksheets all nice and in order so that way you can be using them to do your skills sheet and I can grade them super easy when I come around. And then your homework is just in your spiral, open up so I can just peek at it when I come